Hi everybody, today we're going to go over some logarithm stuff. Just the basics of logarithms, what they are, what it means, how to put it in your calculator, how to rewrite it, things that you've seen before. We'll just go back through them. Alright, so basically a logarithm is just a way of writing exponents. That's it. Logarithms and exponents are the same thing. They follow the same rules. So the base, right? So the base is what holds up your power. So the exponential form of this, you would put the base first. Here's the power over here, and it equals that answer. So I like to think of it as this down here. And you may have heard the word swoop. So you start here, you swoop it over to here, and you come back inside. So a lot of times with logarithms, you're not really doing anything. You're just moving stuff around. Often the question and the answer are sort of built in. Now, when you have log base 10, you don't really write the 10. This is called the common log. And the base 10 is implied, and you don't need to write the base 10. It's not wrong. It's just a little extra. So let's go back and forth between exponential and logarithmic form. This is important because you can put these in the calculator in the logarithm form, but you cannot put them in the calculator in the exponential form. So you have to be able to switch back and forth. So again, we start at the base, so we go as far away as we can, and we come back inside. The answer we get should be a truthful statement. 9 squared equals 49. There's nothing missing, so it's not like we're answering any question. We're just rewriting, so we're just moving stuff around. So again, remember, with no base, that's base 10. Come all the way over here to the 3. And I believe this is a typo. Got too many zeros there. This should be 1,000. Over here we have 9 is our base. The power is 3 over 2. And of course that equals 27. Now this might be something you're not as familiar with. When you have a fractional exponent, it's power over root. So this is basically saying 9 to the 3rd power square root. It's much easier to type in your calculator as a fractional exponent. So fractional exponents are just easier for the calculator. They're a little bit weird to look at, but they're easier for other things. Number 4 is way over here. Now we're going to take this and put it in logarithmic form. So you start with the word log. The base comes next. Of course, it equals the power, and the answer goes next to the base. So the power goes as far away as possible. This one would be log base 3. The answer is 1 over 81, and it equals the exponent. The reason we want it to equal the exponent is because a lot of times the exponent is where the letter is. And so this will be how we get the letter isolated so we can solve the problem. For this one, we have the base 12, so log base 12 of 2 radical 3 is equal to 1/2. The 1/2 power is the square root. So the square root of 12 is 2 radical 3. So that does make sense. Now for this one, this is just kind of made up. We don't really know. There's no truth here because we don't know the numbers. But this is log base x of 15 equals y. So it's really just about moving stuff around and not really doing too much else to it. Finally, we'll get to some that have some parts that are missing. And you can see that there's no equal sign. If it helps you, you can put the equal sign and put the variable there if that helps you to kind of see it a little bit better. But often in logarithms, there's just no equal sign, and you just have to know that they're asking you to find something, which is a little bit weird, but it's the way it works. So this will be 6 to the x power equals 36. So you may know this just in your head, but the trick to this is to get the bases to match. We're going to make the bases match. So I know you know the answer is 2, right? So we have 6 to the what power? 36 can be written as 6 squared. Once the bases match, you just take the powers and make that an equation. So we know that x equals 2. Now, some problems you won't have to do that with, but that's how it works. So let's go through this one. 2 to what power equals 128? Well, this might be kind of guess and check for you because maybe you don't know. So put it in the calculator, 2 to the 5th, 2 to the 7th, 2 to the 10th, and see what you get. 128 is actually 2 to the 7th power. So again, we get rid of the bases, and we know that the answer is 7. This is 10 to the what power is equal to 1 over 100. Well, we're going to rewrite this a little bit. 100 can be written as 10 squared. You want the bases to match. The bases don't match here. This is a 10, this is in the denominator. So in order to pull something up out of the bottom of a fraction, you make the power negative. Negative exponents make fractions, not negative numbers. And so once the bases match again, we can see that x equals -2. And for this last one, 8 to the what power is equal to 1. Well, this is just something you'll have to know. Everything, anything, all things to the 0 power is a 1. Letters, numbers, negatives, radicals, doesn't matter. All the things. So anything that ends up with an answer of 1, we know the power has to be 0. Now on occasion, and by on occasion I mean quite often, I don't know why I said on occasion, I was dumb. You're gonna have some that you can't do that too, right? If we had a problem like 2 to the what power is equal to 15, you can't make the bases match there. So this is often what's going to be happening. This is where we're going to use the calculator. Now in your calculator, or on your calculator, if you go to the math key, the third one down on the left, don't go left or right, but just start arrowing down or up. It's up to you. You can get there either way. You're looking for something that says log base, and the base is like capitalized like this. If you have that key, then you don't need this formula. So look at your calculator. If you don't have this key, then you need this formula. So it's kind of up to your calculator as to what you need. The calculator is based on the age of the operating system. It's not really something you can download or put on your calculator. The change of base formula, I'm going to put over here. We're going to, instead of using the log with a certain base, we're going to switch everything to the common log. And this is the log of A over the log of B. No base, just the common log, because every calculator has that button. Basically, the base, goes on the bottom. So if you have the key on the calculator, try these and see what you get. See if we get the same answer. If you don't have it, put these in the calculator this way. We're going to have the log of 2, and again, that's the common log, the LOG button. But the base of 6 goes on the bottom. Now, when you put this in the calculator automatically, when you push log of 2, automatically gives you that parentheses. You are going to have to close the parentheses, then hit the dividing key, and then type in the log of 6. Now, the calculator will open that. At the end of the problem, you don't have to close the parentheses. You can if you want to. We go to 3 decimal places always, and this should be 0.387. If you're not be able to get that value, let me know, and I'll help you in class. So you got to make sure you can do this in the calculator, because you don't really know what the answer is. You're trusting the calculator. So if you don't type it in right, we're in trouble. So we're going to have, on this one, the log of 1/2 goes on the top, and the bottom, of course, is the base, log of 8. So when you type this one in, you can do log, it's going to do this. You're going to do 1 divided by 2. Close that. Then you're going to hit divided by log. It opens the parentheses of 8. You can close it or not. Or use your log base key. This is -0.3, and it fills the screen, so I'm just going to write it as -0.3 repeating. Now we have one more logarithm that's on the calculator, and this is important that you know that this log is base E. This is the natural log, and that's another type of log on your calculator, but this is very specific. It has base E. So just like the log base 10, you don't see the base. Natural log, you won't see the base. It's just not there. You just have to know that it's an E. So we're going to again swoop these out, but remember, this is an E right here. So E to the 4th equals X. E to the 4th equals X. This is a base E here. E to the X equals 10. All we're doing is rewriting this. We're not really solving it. This would require that you have a calculator to do this, like E to the 4th. That's a real number. You'd have to put it in the calculator to know that. To write this, as soon as you see E, you use natural log. Now, you don't have to write base E. So the answer comes next, and it equals the power. Again, as soon as you see base E, natural log, X Power is over here, 0.5. To put this in the calculator is very simple. There's no special key required. You just push the natural log key, and again, it will open up the parentheses for you. It's automatic. You just hit the 64. You can close it or not, but this is 4.159. And of course, the natural log of 0, you get an error. This is important to know that this does not exist. So does not exist, or you could put no solution, or you could put not possible, or you could put circle with a line through. It's up to you, but it does not exist. You can also not take the log of 0. You cannot take the log or the natural log of something negative. All these things don't exist.